Okay, I'm continuing on to talk about Scratch and this BBC microbit and how we can make various breadboarding activities with these outputs and inputs. If I press a button, it lights up an LED light. And look, I'm pressing the button, and this is making the cat bounce around on the screen each time I press a button. So this is just an introduction to how your kids can begin to learn about electronics using Scratch. If you're going to put together a little breadboard like this with these very inexpensive buttons and wires and LEDs, notice first of all that each LED has a resistor on it. You don't have to solder the resistor like I did. You can plug the resistor into the breadboard in line with the leg of one of the legs of the LED. Notice also that I've got my ground wire coming to the blue rail from ground, and the importance of that is we're jumping the ground to one of these legs, one of the four legs on each button. And we want to make sure that we're connecting our data wire to a different leg. We don't want to connect this wire to this leg because it'll be in line with this ground and then it will not send a signal. Those are the two main things I want to talk about with how to set up a simple breadboard for your students to learn about electronics, physical electronics, with the BBC microbit and the Scratch system. We had to install an extension called microbit, and these are the blocks we get when we install this extension. If we click right here, lower left, you can see the extension. Now, that will not function unless you have first installed what's called a hex file, HEX file, into this microbit so that it can communicate with Scratch. Because this is normally programmed with MakeCode. So we're now using the Scratch environment in our microbit because we have this extension. So here's where we get our Scratch link, a page that's called Scratch MIT EDU microbit. When we click on download the link, we will get the hex file in our downloads folder, and then we just drag and drop it onto the microbit, which presents as a separate drive on your computer when you plug a USB cable from the microbit into the computer. You'll see the microbit show up, and then you just drag this hex file. Now, this may download as a zipped file folder. If that happens, then you need to unzip it. I usually click extract all, and that that will unzip the folder. Okay, that's that. Now, where do you get the microbit? Here's one example showing cost of a simple microbit. Notice that this says V2, which is the latest version of the microbit. I'm using version 1 and it works very well. So you don't need the more expensive version 2. I'm now going to show you. This is our video yesterday showing how this works. And here it is on eBay, a little less expensive. $19 or best offer free delivery. And this says version 2. This one does not say version 2, so I would be a little concerned about that if it makes any difference to you. For our programming purposes, it doesn't matter whether we have version 1 or version 2 of the microbit. All these other pieces and parts are available. This is called a breadboard, and they're defined in size by the number of these little holes, which are called tie holes. You'll see them described as so many tie holes. This seems to work best for me for the purposes of introduction for kids on how to use electronics and Scratch. It appears that any of these tools are functional when we use any one of the on-pin connected 0, 1, or 2. That's all they give us is 3 possible pins, 0, 1, or 2. But then so far, all of the other functions seem to coordinate with that. In the case that we press a button and make a connection, and I just wired the LED lights in so that students can see that they pressed the button and the connection was actually made. And of course you can actually see the sprite move around when you press a button. Again, it's all by Bluetooth. We need to make sure that our Bluetooth is available when we click on microbit. It then connects by Bluetooth. Scratch link down here. I've noticed that sometimes I click on that and I get this message that apparently this means that Scratch is already running, and if you get this message, I found out that you can undo that message by clicking on Control, Shift, and Escape all at the same time. That will bring up a window. You select or search for Scratch, select Scratch, and click to close it, and then this will work. All right, there'll be more about all this. We're having fun with electronics. Very simple way of showing how electronics works for kids. To learn about coding. If you have any questions about how this wiring is set up, I can answer them in the description of this video. If you stop the video, pause it, you can see how my wiring is. I've just got voltage going to the right leg, in this case, of each LED, and then ground going to the button, corner of the button, and then the data line 0, 1, and 2 going to the other corner of the button, and then the ground leg of the LED, the resistor, is plugged into one of the corners of the button. That way when you press the button, it makes the connection. All right, there'll be more.